Welcome to The Explainer. This is where we take some pretty big topics and, well, we break them down. Today, we're diving into a really cool piece of wireless tech called Li-Fi. So let me just ask you this straight up. Can your light bulb give you an internet connection? I know, it sounds a little bit like science fiction, right? But what if the very same light that's lighting up your room could also be streaming this explainer to your screen? That's the big idea we're going to unpack today.
All right, let's just get right into it. What in the world is this technology that's trying to turn basically every light into an internet connection? Okay, so Li-Fi stands for light fidelity. And here's the deal. It's a wireless system that uses visible light. Yep, the same stuff coming from an LED bulb to send data. Now, this is a huge deal because unlike Wi-Fi, which uses radio waves, Li-Fi is playing in a whole different league. We're talking about the visible light spectrum. That's a space that is literally thousands of times bigger than the entire radio frequency spectrum we use now. The potential for speed here is, well, it's pretty mind-boggling.
That might sound super complex, but the idea behind it all is actually incredibly simple. It's all about teaching a light bulb how to speak the language of computers. And here's how it works. You know how all digital data, your emails, your movies, everything, is really just a long string of ones and zeros? Well, Li-Fi translates that binary code into a simple instruction for an LED. If it sees a 1, the LED turns on. If it sees a 0, the LED turns off. That's it. It's kind of like Morse code, but for the digital age, using light and happening at an insane speed.
Now, of course, you're probably thinking, wait, I don't want my desk lamp to turn into a strobe light, and you'd be right. The real magic here is that this flickering, this on and off switching, happens millions, sometimes billions of times per second. It is so ridiculously fast that to our eyes, the light just looks totally normal, totally stable. But all the while, it's beaming down massive amounts of data.
So we get the basic on-off idea, but how does that actually become a working system? Let's follow the data on its journey all the way to your device.
The whole thing really happens in 3 main stages. First, you've got the light source, your standard LED bulb. Second, that light gets modulated. That's the super fast flickering we were just talking about. And third, that light signal travels down to a receiver, which is a little thing called a photodetector that actually reads the light. This picture here shows us that whole flow perfectly. You've got data coming from the internet into a special LED lamp. That lamp then beams the data using light, and a receiver on your device catches it and makes sense of it all.
Let's look closer at step 1. That LED lamp? That's our transmitter. It's taking the data stream coming in and it starts to modulate the light, encoding everything into that high-speed flicker. And then for step 2, you've got this photodetector on, say, your laptop. Its whole job is to capture that flickering light. It's built to see those crazy fast flickers and translate that pattern of ons and offs right back into the ones and zeros your computer understands. Boom. From light back to data. Just like that.
So if you're going to remember anything, remember this. Li-Fi is a really simple but powerful idea. It uses the massive wide-open visible light spectrum with just regular LED bulbs. And the whole thing works on a simple principle. On means 1, off means 0. And a little light sensor on your device catches it all.
A technology like this really just opens up a whole new world of possibilities. It really makes you think, if our ceiling lights can be part of the internet, what else could be? Your car's headlights? Street lamps? What other ordinary things could suddenly become part of our connected world? It's definitely something to think about.